Copyright infringement. Matrix algebra. Addition of matrices. If A and B are both MXN matrices, then the sum of A and B, denoted A plus B, is a matrix obtained by adding corresponding elements of A and B. A plus B equals B plus A. Matrix addition is commutative. Matrix addition is associative. Scalar multiplication of matrices. If A is a MXN matrix and S is a scalar, then we let Ka denote the matrix obtained by multiplying every element of A by K. This procedure is called scalar multiplication. Properties of scalar multiplication. The MXN 0 matrix, denoted 0, is the MXN matrix whose elements are all zeros. Multiplication of matrices. The multiplication of matrices is easier shown than put into words. We multiply the rows of the first matrix with the columns of the second, adding products. Find A, B. First we multiply across the first row and down the first column of adding products. We put the answer in the first row, first column of the answer. We multiply across first row and down the first column, so we put the answer in the first row, first column. Now we multiply across the first row and down the second column, and we'll put the answer in the first row, second column. Now we multiply across the second row and down the second column, and we'll put the answer in the second row, second column. To multiply matrices A and B, look at their dimensions. If the number of columns of A does not equal the number of rows of B, then the product AB is undefined. Now let's look at the product of BA. Across the first row as we go down the first column. Across the first row as we go down the second column. Across the first row as we go down the third column. Across the second row as we go down the first column. Across the second row as we go down the second column. Across the second row as we go down the third column. Across the third row as we go down the first column. Across the third row as we go down the second column. Across the third row as we go down the third column. Completely different than A and B. Commuters, beware. A, B, B, and A. Properties of matrix multiplication. It is possible for A and B to equal B and A. Yes, it is possible. Identity matrix. An NXN matrix with 1 on the main diagonal and zeros elsewhere. What is AI? What is IA? Multiplying a matrix by the identity gives the matrix back. Can we find the matrix to multiply the first matrix by to get the identity? Let A be the NXN matrix if there existed a matrix B such that A and B equals B and A equals I. Then we call this matrix the inverse of A and denote it A to the negative 1. If A has an inverse, we say that A is non-singular. If A to negative 1 does not exist, we say it is singular. To find the inverse of a matrix, we put the matrix A, a line, then the identity matrix. We then perform row operations on the matrix A to turn it into the identity. We carry the first row operations across this right-hand side. We will turn into the inverse. Check this answer by multiplying. We should get the identity matrix if we found the inverse. We can use A-1 to solve a system of equations. To see how, we can rewrite the system of equations as matrices. AX equals B. Left multiply both sides by the inverse of A. This is just the identity. But the identity times a matrix just gives us back to the matrix, so we have this thing gives us a formula to finding the variable matrix. Multiply A inverse by the constant. Your calculator can compute inverse and determinants of matrices. To find out how, refer to the manual or click here to check out the web.